Welcome. Today we'll be discussing section 2.7 with elementary trig equations, specifically cosine, and we'll go through several examples. So the preferred interval with y equals cosine x is from negative pi to pi, exclusive of negative pi, inclusive of pi. If we have y not within the range of cosine, that is -1 to 1, then we have no solution. If y is equal to -1 and 1, or 1, then x naught is equal to cosine inverse of y. And if it's somewhere in between -1 and 1 exclusive, then x naught is equal to negative cosine. There's a negative here. Negative cosine inverse of y, and x1 is equal to cosine inverse of y. So how can we represent this? What's all solutions? And this is to cosine. Y equals cosine of x is simply x is equal to plus or minus arc cosine of y plus 2 pi n. So we're going to get one value, two value, and just add 2 pi n to it. Okay. So let's have an example. We have find all solutions to cosine of x equals negative square root 2 over 2. So what we want to do is go, okay, we want to draw our formula and say x is equal to plus or minus cosine in our cosine of y plus 2 pi n. We replace y with square root 2 over 2, negative square root 2 over 2. And so now we have to think what angle gets us that in the range of cosine. And we'd say that 3 pi over 4 would achieve us a negative square root 2 over 2. So that is what our cosine of negative 2 over 2 is equal to. We're going to throw in the plus or minus in front of that and add 2 pi n behind it, and that'll equal our x. And that's all of our solutions. And if we want to find the base solutions, we can then apply this formula and say, okay, our base solution, we want the negative version of this. So x naught is equal to negative 3 pi over 4, and x1 is equal to 3 pi over 4. Okay. So let's see some more examples. Let's find all solutions of cosine of 2x minus pi over 3. And we're saying that this equals 1/2. We want to find all possible values of x. So we want to first make a substitution. So this I'll be using the substitution method. Let a be equal to 2x minus pi over 3. And now this problem becomes cosine of a is equal to 1/2. So now we can solve this and get an answer, but instead of getting x to sum all solutions, we're going to get a, and we simply just make a substitution for a in terms of x and solve from there. That's the idea. So what do we get? We have a is equal to plus or minus cosine inverse of y plus 2 pi n. Okay, well, we can substitute in for our y, which is 1/2. We can look at our unit circle and say, okay, cosine of 1/2, that is pi over 3. So a is equal to plus or minus pi over 3 plus 2 pi n. And now we say, okay, well, we didn't really want a, we wanted x. So we're going to write this as 2x minus pi over 3 is equal to plus or minus pi over 3 plus 2 pi n. Might look a little weird, but we can simplify this. We can just add the pi over 3 to the other side, divide by 2, and so we get, well, let's do it in steps. 2x is equal to plus or minus pi over 3 plus pi over 3 plus 2 pi n. It's addition. We can write this in any order. I prefer writing in this order because I have plus or minus. This is meaning that this could be either 1, and I have a constant, and then here I have a variable that's an integer that I can just plug in any such integer into this. So now I divide by 2, I have x is equal to plus or minus pi over 6 plus pi over 6 plus pi n, because I divide by 2 and it cancels out with that 2 there. All right, and that would be my answer. Yeah, well, let's see another one of this. And this one, write down this example and how we solve it. This will be your check on learning for your weekly submission. So, example. We want to find all solutions of 2 sine squared of, let's do theta minus 3 sine theta minus 2 equals 0. So again, we're going to look for a substitution on this. So we're going to let a be equal to sine of theta. So we get that this becomes 2a squared minus 3a, and this is minus 2 equals 0. This is now a quadratic equation, and we can try to separate this. We can also plug this into the quadratic equation. Let's do the latter. And we have a is equal to, let's write it over here. A is equal to negative b, so that's 3 plus or minus the square root of b squared. So we have 9 minus 4a 2c is negative 2 all over 2 times 2, which is 4. Okay. Solving this through, we get A is equal to 3/4 plus or minus, and we can evaluate this. We have 4 times 4, so that's 16. 9 minus 16 is, or 9 plus 16 is 25. So square root of 25 is 5. We're at 5/4. So that means that we have A is equal to 2, because I can add 5/4 to this, so I get 8/4. 8 divided by 4 is 2. Or A is equal to, I'm going to have a negative, so 3/4 minus 5/4 is negative 2/4, so that is negative 1/2. If you saw how to break this apart into these nice values, kudos to you, but quadratic formula will never fail you. All right, so that's part of our answer, but now we still need to make it in terms of x, or sorry, in terms of theta. So what we've done here now is that we've said that A was sine theta. So we have sine theta is equal to 2. And then we also have sine theta is equal to negative 1/2. So sine theta is equal to 2. That is outside of the range. So there's no solution here. In other words, this doesn't contribute anything to what theta could possibly be. This is within our range of -1 to 1 inclusive. So we can now state we can state that theta is equal to -1 to the k arcsine of -1/2 plus k times pi. So we look on our unit circle and we find -1/2. It has to be within the domain of arcsine. And we get that this is -pi/6. We're going to put a -1k out in front here and plus pi times k. Okay. So the last thing is that we want this to be our base, and so we want it to be a positive value. And we can simply just take out a negative and store it into this guy up here. So I can rewrite this as theta equals -1 to the k plus 1 times pi/6 plus pi k. That is a simplification that that is good to see as far as like getting a base value and being positive here. It's not strictly necessary, but any form of the equation, I'd accept either, is a valid solution. Okay, so let's look at a couple more examples. And again, for your check-on learning, it would be to submit this example, example number 2, for your weekly check-in. So here's example 3. And we're going to find all solutions to cosine squared of, let's do 2t minus 3 cosine of 2t plus 2 is equal to 0. We can do pretty much the same trick and say a is equal to cosine of 2t. So then this becomes a squared minus 3a plus 2 equals 0. And let's factor it this time. We have a minus 2, a minus 1 is equal to 0. So a is equal to 2, and or I should say a is equal to 1. So what that means is we have cosine of 2t is equal to 2, and we have cosine of 2t is equal to 1. We can throw out the cosine of 2t is equal to 2 because that's not within the range. Cosine of 2t is equal to 1, that is definitely within the range. And so now we can evaluate that. And we have that 2t would be equal to plus or minus arc cosine of 1 plus 2 pi n. So we look and see what is arc cosine of 1, and we see that that is 0. So we just have 2t is equal to, and we have 2 pi n. Now, you might ask, well, what about the plus or minus? And I'd say that, well, this n could be positive or negative, and so we get all the solutions that we can with that. We don't have to worry about it because this guy was 0. And so now we divide by 2, and we get t is equal to pi n. Now note, n is an integer, and I would include that within your answers to be very scrupulous, but generally, whenever you see a variable k or n, it's an integer unless otherwise specified. All right, moving on. Example 4, we have find all solutions to secant squared u equals tangent u plus 1. So from here, we can rewrite secant squared u as 1 plus tangent squared u equals tangent u plus 1. Let's get it all to one side, and I'm going to write down tangent squared u minus tangent of u is equal to 0, because this one cancels out with that one. And I'm just going to subtract the other tangent across. Note, I am not dividing by tangent here. I can't just divide and say, oh, what's tangent u is equal to 1. I can't do that because I don't know if tangent u is 0. It could be. So instead, I'm going to subtract it, and now I'm going to factor it out. And so now I have tangent of u times tangent of u minus 1 is equal to 0. And so now we can look at this and view it as tangent u equals 0, and we have tangent u equals 1. I can take each one of these separately, and then this one I'm going to add the one across, and that results in these two equations. We could also substitute with a, and we get to the same spot. But so now we have to ask, okay, we have u is equal to tangent inverse of 0, or u is equal to tangent inverse of 1. Let's start with tangent inverse of 0. We know that that is 0. So we have 0. So let me be scrupulous with this being, we have to add pi n. And we're going to add a pi n here. And now we know that this is 0, so we just have u is equal to pi n. And then we have u is equal to tangent of 1, or tangent inverse of 1 is pi over 4. And we're going to add pi n. So this is the answer to the fourth example. So again, we could have substituted an a in here if you needed to. That's perfectly fine. We would have gotten to this same step where we'd have a is equal 0, a is equal 1. In this case, I skipped it and was able to infer that tangent of u is equal 0, tangent of u is equal to 1. And we then found the inverse function, and we added all possible solutions to each inverse function and simplified. I will state that it is important to have this or statement here, because you could be in this solution set or this solution set. Notice the lack of or in this statement because I was highlighting that this statement and this statement are the same set, and theta is just a part of one of them. But either answer is acceptable. So don't be confused about that. That is all for this lecture. There will be an optional video posted later this week, and it will take just a random sampling of examples for the upcoming test. Thank you for watching, and have a great day.